let's discuss these three improper integrals. They are the first type of improper integral where there is an infinite interval. Infinite interval means there is an infinity either on the upper limit or the lower limit. So the first one we have integral. And then from 3 to infinity, we have x equals to 3 to x equals to infinity, 1 divided by x minus 2, 3 over 2 dx. So this one, let's set up the improper integral first. Start with an equal and then write the limit. That is not optional. Limit as t approaches to infinity, we have 3 to t and then 1 over x minus 2, 3 over 2 dx, and then this one that is a u substitution problem, right? So we have u equals to x minus 2 and then du is equals to dx, and then how do you write the limit? So the limit, when you learn u substitution before, do you still remember this? The upper limit and the lower limit, they are in terms of x, so you have to put them in terms of u by doing u infinity, right? And then u of 3. Do you have to do that in here? The answer is no, we will not do those in here. I will just do this. So we have limit as t approaches to infinity. So that will be what? That will be the integral of 1 over u to the 3 half, right? So I will just do u to the negative 3 half and then du. What about the upper limit and the lower limit? Just do not write the upper limit and the lower limit. You don't have to do u of infinity and u of 3. Just don't write them out. Now integrate limit as t approaches to infinity. So this one follows the simple power rule. So first you add 1 to the powers. So negative 3 half plus 1 is negative 1 half. And then the reciprocal of that is equals to negative 2. And then you put the x back to the u. All right. So you have limit as t approaches to infinity, we put the x back. So we have a negative 2. And then once you put the x back, you have x minus 2, right? So you have x minus 2 to the negative 1 half. And then such that x goes from 3 to t. All right. And then we have a limit as t approaches to infinity. We have negative 2, plug in the t, you have infinity. Oh, just write t minus 2, and then minus negative 2, and then square root 3 minus 2. All right, so what happened when you plug in an infinity? So you have negative 2 divided by the square root of infinity, which is equals to infinity, right? And then plus 2 divided by 1. So basically you have a 0 plus 2 that is equals to 2. So since this is a number, not infinity, we say the integral is convergent. Convergent means we have a finite area. All right, so that's the first integral. Let's take a look at the next one. The next one, we have a negative infinity on the lower limit. So we have negative infinity to 0, from negative infinity to 0, and then 1 over 3 minus 4x dx. So let's set up the limit. So we have limit as t approaches to negative infinity. We have t to 0, 1 divided by 3 minus 4x dx. So this is a very simple u substitution. We let u equals to the denominator, 3 minus 4x, and then du is equals to negative 4 dx. And then we have negative 1 over 4 du equals to dx. It is not necessary to do this. So u of 0 and then u of negative infinity. So this, you don't need to do it. Don't worry about this. All right, so we have limit as t approaches to negative infinity. So we have the integral of 1 over u, right? So the integral of 1 over u, the dx is equals to this. So let me do a little highlight for you. So the dx is equals to negative 1 over 4 times negative 1 over 4 du. Just do not write the lower limit and the upper limit. Just leave that blank. And then now we integrate. So we have limit as t approaches to negative infinity, negative 1 over 4 ln absolute value of u, right? So the absolute value of u, let's replace the u by x, so we can erase the u and then just put the x back. That is 3 minus 4x, and then x goes from t all the way up to 0. All right, so let's plug in the 0, plug in the t. So we have limit as t approaches to negative infinity. So we are doing the fundamental theorem of calculus. Ln, so you plug in the 0, then you have a 3, and then the absolute values becomes optional. But if you keep the absolute value in there, absolute value of 3 is just equals to 3. I won't erase that. And then minus negative 1 over 4 ln absolute value 3 minus 4t. All right, so now we have a limit. The integration is done. So we have negative 1 over 4 ln 3, do not approximate that. That is just equals to a number, and then plus 1 over 4 ln. So you have 3 minus 4 times negative infinity. So 3 times minus 4 times negative infinity. So negative, negative, that becomes a plus. So you have a 3 plus infinity. That is just equals to infinity. So therefore, we have ln of infinity. So what is ln infinity? Ln infinity is just equals to infinity, right? So this is a negative 1 over 4 ln 3, and then plus a huge value, and then at the end of the day, the area is equals to infinity. So therefore, we have an infinite area, and the integral is divergent. So regarding the graph of Ln, the graph of Ln is an increasing function. We have x-axis and y-axis, and there is a x-asymptote at 1, 0. X is equals to 1, y is equals to 0, and this is the graph of Ln. So on near the y-axis, as x approaches to 0 from the right, we have y approaches to negative infinity, right? And then on the other side, as x approaches to infinity, y approaches to infinity. So therefore, ln infinity is just equals to infinity. All right. So that's the second one, and then we have one more to go. The next one has an ln in it. So we have integral from 2 to infinity e to the negative 5x dx. So that is equals to limit as t approaches to infinity. We have from 2 to t, and then e to the negative 5x dx. This is a u substitution. We let u equals to negative 5x. du is equals to negative 5 dx, and the negative 1/5 du is equals to dx. And then we do the change of variable. Limit as t approaches to infinity. We have what? We have negative 1 over 5, right? Oh, okay. So let's do the e first. We have e to the u, and then the dx. The dx was right here, and then will be replaced by the negative 1/2, so multiply negative 1/2, 1/5, and then du. What about the lower limit and upper limit? Just don't write them. Okay, so just don't write them. And then the integral of e is still equals to e, so t approaches to infinity. We have negative 1 over 5 eu, right? So eu, you put the x back to the u, so you can go ahead and then erase that, and then put the x back, that is negative 5x, and then such that x goes from where to where? From 2 to t. And then you do the fundamental theorem of calculus, so this is the FTC, and then you have limit as t approaches to infinity. Oh, by the way, when you do improper integral on quizzes and exam, don't forget about the limit. If you forget about the limit, you don't start with the limit, there is no equal sign on your work, your instructor is going to be really, really mad when they grade your work. You have negative 1 over 5 e to the negative 5t, and then minus negative 1 over 5 e to the negative 5 times 2 is negative 10. Okay, what do you have right here? So you have limit. Okay, let's just plug in the infinity, shall we? So you have negative 1 over 5 e to the negative 5 times infinity is negative infinity, and then minus minus, you get a plus 1 over 5 e to the 10. How about this? We put that in the denominator. All right, how do you handle the infinity? So you have negative 1 over 5 times e to the infinity, and then plus a number. So e to the infinity is equals to infinity, so you have negative 1 over infinity plus that number, so which is equals to 0 plus that. So this is equals to 0, so that is equals to 0. So overall, you have 1 divided by e, 5 times e raised to the 10. So that is my answer. So that is the area under the curve. So the area is finite. So we write finite area, and therefore the integral is convergent. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, subscribe to my channel, share the video for me. Appreciate for your help and support. I will do a few more first type of improper integral in the next couple videos. See you there. Signing off for now.